All right, did everyone have a good lunch? Yeah, all right, I don't know why I asked that. Okay, so thank you for the introduction. So I don't need to introduce myself, but I will add that there were some wonderful contributors to this project who are here. James Meacham, who's the director of the Infographics Lab, and just as a side note, this year's the 30th anniversary of the University of Oregon Infographics Lab. So a lot of... Sorry, I need to be closer, apparently. So congratulations, and thank you for welcoming to that team about a year ago. Then we also have a student, Ben, who's here today, and this project has been a partnership with Daniel Rosenberg, who wrote this phenomenal book, Cartographies of Time. So he's a historian, but we really need to get him here, and we're going to tell him how much we love his work, so he'll come. And he looks at how time has been represented throughout history. History of history, it's very meta, and I love that. And so he looks at timelines that look like this. It's a soldier, and many more other interesting ways that time is represented. And there was a change that happened in time where they switched to representing time as a linear from left to right, something that is intrinsic to us now, that when you see a timeline, regularly intervaled representations of space could be years or minutes or hours, and it wasn't always that way. And this chart, which was created in the about over a dozen years in the late 1700s, was that transition in time. It was created by a philosopher, clergyman, political theorist who's actually more well known for discovering 10 gases, including oxygen. But he was a cartographer on the side. And he actually, for his work with these charts, there were 15 editions that were printed, showing the history through time of who was in power where. The University of Edinburgh actually granted him a doctorate of law for this work. My favorite actual part of this is, it's hard to see in the cursive, but next to the picture of Priestley there, he wrote, "To Benjamin Franklin, this chart is in testimony of esteem and friendship, transcribed by his most humble servant, Joseph Priestley." So if you don't have a map to put over that high contrast spot on your map, think about making a dedication like that to someone in this room. I think that would be wonderful. So breaking down how the chart works, when you look at it, as I mentioned, time is across the top in a timeline. The chart itself goes from 1200 BCE till 1700 CE. Each row depicts a geographic place. So we've got 180 rows, or 180 places in the world, that were then grouped by 20 different regions. As you can kind of see on the side, America is that first one. And I've highlighted where we are now. That's the, let me look closely, Pennsylvania, Maryland, and Virginia row. So coming on quite late in time, actually, compared to the rest of the chart. Labeled areas depict which regime was in power of a given place in a given year. So if we look at the place row and find a given year across the top, who was in power? So here in Virginia, the English were in power kind of more recently. But across the chart, you'll see more familiar or less familiar groups that were empires, or sometimes we refer to them nations, depending on the era, or tribes early on in the chart. Vertical lines in this really dense and amazing infographic represent changes in power. So sometimes we see dotted lines, sometimes we see dashed lines. There might be a solid line or no line at all. And all of these have coded meaning about how the transition from one power to another took place. Was it violent, was it not? Vertical lines represent an abrupt, short period of time where we changed power, so maybe a war. But there are also longer transitions of power that are slanted lines. You can see sort of in the bottom left, right, I'm facing the other way, but in one of the sides, there's angled lines in the Saracens. Transitions may take sometimes 10, 50, or even 100 years over a range of places to go from one regime in power to another. So this historian came to us and said, "You're cartographers, and this is about place," and said, "Here's my goals for the project. I'd like to create a digital version of this chart in a data-driven fashion, and data-driven so that we can identify what on the chart was procedural and what was artistic license." It's so methodic in here. He didn't use computers, but the processes that he used, the rules that he followed, you can actually understand the data that's in it because he followed those procedures so strictly. And additionally, what happens if we add on from 1780 till now? If we follow his rules, we can extend the chart to the present day. The next is facilitating interactive exploration of the chart. Right now, the best way to look at it is with a magnifying glass, or if you can find one of the originals, which are about 12 feet tall, you can stand up and read it off the wall, which actually here works. I think the projectors make it about real size. And just have the ability, how can we pull more information out of it in kind of the web interactive formats that we use today? And lastly, to investigate Priestley's spatial assumptions. How does the chart, that graph of the world, misrepresent actual geographic space? And how does the order of the rows? How did you choose what's at the top and what's at the bottom? This is more than when we talk about projections, right? What's in the middle? Where's north? What do we stretch? How do you order in a linear fashion 120 places in the world? And what happens if we switch the order of that rows? Does it change the information that the chart is giving out? And when I first was told about this project going on in the lab, I was like, yes, let's do it. This sounds like I'm game. Let's try and do this. So I think I'm actually going to start with goal 3 because I'm in a room full of cartographers, and I think the elephant in the room is like, that's not a map. So we're going to start there and talk about what happens if we make it a map and how does Priestley misrepresent geographic space. So first, let's talk about what are these places. So if we zoom in very closely, we can see that section of the Americas, which we're in now. Most of these places I think we would know. I think a lot of people in this room, this is NACIS. We were in Montreal last year. We know where Canada is, right? Did Canada look like that, though, in the 1780s? Right? We have a road depicting Canada there. Where actually was that place? It's a question we're faced with. Similarly, somewhere that maybe did. If you've been to Sussex, if you've been to Wessex, maybe they were the same when he was drawing this chart as they are now. It's kind of a question that we had. And then additionally, what do we do with these geographic name places that are different in spelling? So for example, Turkey is being spelt without an E. How do we deal with matching all of these regimes in power, places and names? And it came down to looking back to what was available to Priestley at that time. And I also am a lover of the David Rumsey map collection. And from there, we find an Edward Quinn map, which Priestley talks about in his texts when he was creating it. So this is an example of one of Quinn's maps that Priestley would have been looking at when he was writing a row that said Canada. And you can see there's kind of a yellow blob that's there. That's Canada, not the modern day nation that we have today when we're looking at what's in power. So looking through that chart and having diligent student workers who were willing to digitize, we were able to do a geographic interpretation of the named places as well as regions that exist on the chart. So not surprisingly, this chart of the world is lacking a little bit of spatial coverage of some places. And so what we see here is white or the kind of paler is what was represented on the timeline. And the darker black, other way, white is missing and the darker black is what's represented on the timeline. And each polygon on here represents one row in the chart. So something you can already see is there's this really different sizing in what got a row. On the chart, we even actually have half rows and third rows compared to the most basic row. So if we compare that to the chart itself, what I'd like you to take a look at is at the region level, the Americas, north and south, receive about this much space and time on the chart, whereas France receives that much space. And I think we can all tell that maybe that's not the spatial representation that they actually take up. So he's given a lot of emphasis to this sort of Western Eurocentric view of the history of the world. And so when we look at actually bringing up the map, and I know it's Mercator, just accept it, move on. Actually, it just might be unprojected plate, can rewrite it. Anyhow, we've got the regions of the world that were on the chart itself. And Ken, are you in here? Ken Field? There you are. No, I'm going to tell you, this is one of those cases where I thought, you know what would solve this answer for me? A cartogram. Yeah, right? I'm really excited to play with ArcGIS Pro's new cartogram.
Try to take a look.
No, he says they didn't work. For anyone who didn't hear that, no. But that's okay. So what we've done is, so if we look at France and the Americas, and I've created a cartogram here that readjusts based on the data values. Instead of population, this is the values of area given on the chart. So here's our, so you can see that hugely Eurocentric view of the world that the chart has, which I think is interesting for those questions of how did he represent or misrepresent space on that chart. So we do have an interactive site you can go to and animate back and forth between the two. It stretches, it's awesome. So going back to the first goal that was Dan's goal that he came to us with, which is creating that digital version of the chart in a data-driven fashion. And so that was really, to my mind, about interpolation. And so the process that we went through was starting with the chart and actually a PDF document, that was a book that he had that went with it, and having a very diligent history student create a spreadsheet of those many, many rows and columns for every year and every place who was in power, and if there were transitions, recording the before and after and what type of transition that we had. Then we used arcPython, and this is the interesting part. I decided how to deal with this data was I was going to spatialize it. Those are the skills I have. I know how to code, but I'm a geographer, so I decided I know how to dissolve and merge and intersect. I'm just going to make the chart be at UTM zone 0 and go from there. A year is a meter, and we're good. So we then converted that chart into shape files and exported it out to JSON files to display it using the D3 JavaScript library and HiCharts to produce some kind of paired charts that go with it. And the development of it was a really iterative process that involved updates as Hannah coded more and more lines, and exploring how we could reverse engineer the processes that Priestley did. And so this was our first early version. You can tell we're using really default D3 colors, and we'll go through that more. And we moved further and further and further and brought us to what the chart looks like now, which I'll get to. So looking at that process of interpolation a little bit more. So this is kind of what the basics of what the spreadsheet looked like, where we have a region, a place row, if it is a half row or a third row for some of the ones where abruptly there's just a little chunk taken out of it. And so yeah, this was 140 rows and 3,000 columns. Thank you, Hannah. So what I did in order to spatialize this was take the chart and just use some Python in order, I say just, but this was not a just, this has been a really awesome, hard-working project, I created an ASCII file. So number of columns, number of rows, and this part was actually pretty important because we couldn't just take each cell as one because the chart was the wrong shape. We needed to get some areas, there was like a multiplication value to get rows taller, and so there was a little algorithm that I wrote for deciding if something gets extra rows or not, and we create this ASCII table of it. And then in arcPy did raster to polygon, and what we end up with for this particular area that was highlighted in the top, how we had Hannah code was we've got Britons in this one area, and then there's a transition that was many places over many years, and what's coded in was the type of line. It was a solid falling line, SF. And then what we did from there is convert that using raster to polygon, and then take any of these transition polygons and write a little script that runs through it and said, based on the transition, if it's solid falling, find my max top left, my minimum top right, cut it in half, or the other way if it's a solid rising, and store the transition if it was solid or dashed or dot, just write a polyline file from those coordinates. And then I have a bunch of polygons with the same values. We did a dissolve. And now all of my transitions, regardless of rising, falling, vertical down the center, they get merged with their right neighbor. And we have a line that we can symbolize independently as dotted or dashed between them, because you can't do the whole border, because Priestley didn't dash the whole border, so I can't just symbolize my fill separate from my stroke. We had to pull out these lines, and that's how we did it. Store the color for some of the ones that were unique colors. We knew Romans got green, English got blue, everyone else is beige. Store that in a value. Export these features out to JSON and style as needed for the transition power. So that was our digital, and that's the original. And I think we did a pretty good job. So this is taking our Python script, and we've been able to run it from the Excel spreadsheet of the data. So we did not trace it. This is running our scripts, and we've been able to adjust the data. We can change the order of the rows and get a different chart, and we're really excited about it. So the last kind of goal, or the middle goal, was making it interactive. So this, as we were trying to discover, well, what are the different codes? How do we make it work? We also were developing interaction. So our first version, what we could do with that was simply identify a road, and we linked it to the map. So if you knew a year that was based on the x coordinate, so you move your mouse around, we know what year you're in. We could change the sorts right off the bat, because that was one of the earliest. We have our default and our alternate sorts up there. That was one of the early goals. This is plugging in different data, not just recreating the chart, but recreating the process. And latter version we got to, we started playing with making it look a little older with different fills and patterns. We added more data. We looked at being able to select entire regimes. And at this point, this is when we decided to have the event layers separate and went back into the script that originally was just making polygons and started making polylines, so we could symbolize those independently just in the event areas. And we started getting ideas of what are the linked charts that we can put with this to draw out more information than just the chart itself. We got to the point where we could then select, for example, a given year, in this place looking at a place in Spain, Granada, and apologies if I pronounced that wrong, that if we click on that particular place for a given year, well, that was in the Roman Empire. What were all the places that Rome controlled at that point? So we have Granada being in purple on the map, and the row has a little purple hash across it. We've got the time goes across in red. We've got hovering. We can interact with the whole map, and we can see how big the Roman Empire was in that year for the 10 biggest, or 8, I think it is, biggest empires of that given year. Brings us to where we are now, which we have a fully interactive site online where it's in an alpha version. So we can go on there and play, and we have the chart itself. You can interact with it, etc. And okay. We have several different ways that you can interact with it of these paired charts. And Ben will be talking about this UI in Web Mapping 2 on Friday. So if you want to learn more about the charts, then go to that talk. And my concluding thought is it is possible to spatialize non-spatial data and then hack away at it with GIS. So with that, I want to thank Daniel, Jim, Ben, and Hannah for all their work. This is the bit.ly that'll get you to our alpha version. There are interesting things, as I said, it's not beta yet, it's still alpha. So I definitely welcome people's feedback on it, all lowercase, because it's a bit.ly, so keep it all lowercase and you can get to it. And I recommend this book and the paper that where Daniel Rosenberg said allowed this. Thank you.